AP Chemistry Unit 3.4, Ideal Gas Law. Okay, so the ideal gas law is going to assume that there are absolutely no attractive or repulsive forces in between particles. So that means that there are no IMFs at all, and that the particles themselves are going to be negligible in size compared to the size of the container. This is the ideal gas law. It's PV is equal to nRT. P is our pressure, typically in atmospheres. Volume is going to be the amount of space that the gas is going to occupy, or the container in which the gas is occupying. That is typically in liters. N is our number of moles of the gas. R is going to be an ideal gas law constant that is going to be dependent on the pressure unit. And then T is our temperature, which is always going to be in Kelvin. Dalton's law of partial pressures states that the total pressure is equal to the sum of the partial pressures for an ideal gas. So this means that our total pressure is going to be equal to the pressure that is attributable to one of the gases added to the pressure that is attributable to another gas. So if we had a mixture of gases such as nitrogen and oxygen and carbon dioxide, like we do in the air that we breathe, their total pressure that we are experiencing is going to be the sum of the pressures from each of the gases. So the pressure from oxygen, the pressure from carbon dioxide, and the pressure from nitrogen added together is going to be the total pressure that we would experience from that gas mixture. Mole fractions are going to be the percentage of the partial gas within a mixture, and it is going to be pretty easily calculated. The mole fraction is going to be this X, and then the A is going to stand for whichever gas you are interested in. So the mole fraction of, let's say, oxygen, okay, is going to be equal to the number of moles of oxygen divided by the number of moles in the total sample of the gas. So all of the moles from every gas that is inside of that sample. You can also do this to calculate the pressure attributable to an individual gas. So the pressure from oxygen, if that was still our example gas, is going to be equal to the mole fraction for oxygen multiplied by the total pressure.